All right, we are doing the first section of chapter 6 today. It's all about polygons. So we are going to identify and classify polygons. We're also going to find the angle measures in quadrilaterals. So we'll talk about what quadrilaterals are first, and then we'll talk about the angle measures. So first vocabulary term, polygon. Plane, not like flying in an airplane. A plane figure means like on a flat surface, like a plane in geometry. So a plane figure that is formed by 3 or more segments called sides. So those are all examples of polygons.
So a plane figure is a flat surface?
Like a flat, yeah, a plane is a flat surface in geometry. So a plane figure would be a flat figure.
It's not even going to be on.
Okay.
It's going to be on 36.
So number 2, the second vocabulary word is a diagonal. A diagonal is a segment that joins 2 non-consecutive vertices of a polygon. We'll also need to know what the word sides means. You can probably figure this one out, but we'll write it down anyway. Those are the segments that form a polygon, and a vertex is each endpoint of a side of the polygon. So the vertex is like the corner or the angles that are formed. Okay? So I'll give you a few minutes to get those down. All right, so we classify polygons by how many sides it has. So you need to write these guys down. You don't really need to write the word sides 10 times. So triangle, you guys already know that, right? Triangle has 3 sides. Quad means 4. Like some people ride like 4-wheelers, they call them like quads. Or like the quads in your legs. There's 4 muscles, I think. Anyway, quad means 4. Pentagon has 5 sides, just like the building in Washington has 5 sides, the Pentagon. Hexagon, I like to remember the X. 6 is the letter that has the X in it, right? Hexagon has an X in it. I don't really have a memory trick for heptagon. And we'll get there. Heptagon has 7 sides. Octagon, like an octopus, right? Octopus has 8 legs. Octagon, 8 sides. Nonagon has 9. It kind of looks like the word 9. The vowels are different, but 2 ends, you know. Hepta has 7 sides. All right, a decagon, like a decade is 10 years, right? Like we just started a new decade, 2020. Yeah, okay. So same thing, deca means 10. And then here's where it gets a little weird. N-gon is for n number of sides. So like if it has 20 sides, we call it a 20-gon. If it had 50 sides, we call it a 50-gon.
So it would be like
anything past 10. I think 12 has a special name, dodecagon, but if you said 12-gon, I'd be okay with it. So yeah, just 3 through 10 you kind of have to memorize, and then after that you can just go with n. I think there's a few special ones, but yeah.
There's only 9?
I know. Yeah, I think I said 10, but 9.
I'm just trying to figure out.
Yeah, since there's not a 1 or a 2, but there is an N. So yeah, you lose 2 in the front, you gain 1 in the back. Anyway, yes. So these are the ones you need to memorize. Anything past 10, you can just go with that number and then G-O-N for gon. These are also back on that poster right there. So if you start drawing a blank, that goes from triangle to decagon, and then you just have to remember past that, use N. Any questions? All right, here is our first set of examples, and I want to make a little like cheat sheet for you. So, is the figure a polygon? Explain your reasoning. So there are 3 reasons why something would not be a polygon. So we're going to make a list first. So here are just reasons why not. We're going to look at these first. So reasons why not. This is kind of like another vocabulary section in your notes. So reasons why not would be if you have any curves. So if a figure has any curved side, it is not a polygon. If a figure has any gaps it is not a polygon. And then if the figure has any crisscrossing, we'll just say overlapping. Okay? So a polygon has all straight sides, and they all connect at the end of the side. So there's no crisscrossing, and there's also no gaps, no parts that are left open. So, A, is that a polygon? If any of these things are happening, it's going to be a no. So this is going to be a no. And why not? It has curves.
Hold on.
All right, the second one, do you think that's a polygon?
No.
No, why not?
Yeah.
Yeah, you could say actually either one. It has a gap or it has an overlap. All right, what about number 3?
Okay.
Is that a polygon?
Yes.
Yes. And if it's a yes, you don't really have to give a reason, okay? And remember, on number 2, saying that there's an overlap, that would be fine too, since these sides cross one another. So either one of these reasons would work, gap or overlap.
Hold on.
You don't need to draw these, but I do want to just go through a few more quick examples. So we'll just do them out loud. So the first one, the blue one, would you say that's a polygon? Yeah, all the sides are straight. They all connect at the end points. There's no gaps. There's no overlaps. This would be a yes. What about this one?
Yes.
This would also be a yes. All those same reasons. This guy?
No.
No. Why not?
There's a gap.
There is a big old gap right here. Okay. What about this one?
There's a curve.
There is a curve. The whole side is curved. So this would be a no because of curves. Yes?
Yes. No.
No. Some people try to say, well, this is just 2 triangles. It doesn't really work like that, okay? This would be a no because it's overlap. So basically all the ones that are colored would be yeses. All the black and white ones would be no's for all the various reasons. Gaps, overlaps, curves. Questions? All right. Now we're going to transition into the sort of the second half of the class. So this one is all about quadrilaterals. Quadrilaterals have 4 sides. So if you want to make yourself a little note, 4 sides. So if a figure has 4 sides, the interior angles are going to add to 360. So we did this previously with triangles. All the angles would add to 180. Now with that extra angle, they all add to 360. So if you're given 3 angles that you know and you're looking for a 4th one, you just do 360 minus, 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 and that will give you your missing angle. We will also look at some where you write equations. If there's an x anywhere in there, then we'll add the angles together equal 360. Questions? All right, so here's example 3. You can go ahead and draw this real quick. Label the angles. It doesn't have to be perfect. Just draw a figure with 4 sides and label 3 of the angles.
Big like that.
No, draw it whatever size you like. All right, so they should all add to what? 360. So I'm going to do 360 and then what? Minus 60, minus 100, minus 95. Just subtract all of them. And it doesn't really matter which order you subtract. All right, so when you subtract all those, what do you end up with?
105.
105. So the missing angle, it does not look like this would be the measure, but take my word for it, it is. All right, what are your questions? All right, so these are the ones where I guess you could do like 360 minus, and then set that angle equal to 2x, but I'm just going to write the equation from the very beginning. So I know that these four angles, 2x and 50 degrees and 118 degrees and 84 degrees, should all add up to 360. How would I solve that equation? And you don't have to write the figure, but write the equation with me so you get a little practice solving these. So again, just the four angles. 1, 2, 3, 4. All add together, so plus signs to equal 360. Now I need to combine the like terms. So I'll have 2x plus, what's 50 plus 118 plus 84?
252.
252. All right. Then what would I do? Subtract 252. So I get 2x equals 108. Then what? All right, divide both sides by 2, and what do you get for your x? 54. Good. And then if you're like, I wonder if I did it right, you can plug it back in here. So 2 times 54, and then add it to those three angles and see if you get 360. All right, any questions? Okay, 5 we're going to do the same way, only what am I adding this time? Yeah, these are both 90 and 90, and then the two angles up at the top. So I'm going to do 11x plus 81 plus 90 and 90, and that still equals 360. If it has 4 sides, the angles add to 360. Then what? Add the like terms. So 90 plus 90 plus 81. What do you get when you add those?
261.
261. Then what? Yeah, I'm going to subtract 261. So I have 11x equals 99. And then divide by that 11, and what do you get for your x? 9. Perfect. All right, last one, and we can just do it out loud because I know there's one like this on your homework. So I don't want you to be completely shocked when you get your homework. But this is looking at like an actual real life polygon. When would you see these things? A stop sign is actually a real life polygon. So tell how many sides the polygon has and what type of polygon it is. So a stop sign, does anyone just know? It has 8 sides. So you would say 8, and what's it called when it has 8 sides? Octagon. All right, these are the ones I want to look at because there are ones like these on the homework, okay? Vertices is just, that's the plural for vertex. So name the vertices. The vertices are actually the points where two sides intersect. So A would be a vertice or a vertex. Then you can just go around the figure. B would be a vertex. C would be a vertex. D would be a vertex. E, F, G, and H. There should be as many as there were sides. So 1, 2, 3, 4, 5, 6, 7, 8. I got them all. So the vertex, you just use one letter. The vertex is the point. For the sides, you still have 8 answers, but sides are from one vertex to the other. Sides are segments, and we use 2 letters for those. So the sides would be like AB. Does anyone know another side?
CD.
Let's go in order so we don't miss one. AB, then what?
CD. Oh, EC.
BC, yeah, don't miss that one. BC, then what?
CD.
CD. DE. EF. FG. GH. And then everyone kind of forgets to like finish it off. You still got to go back to A, right? So HA. So it's the same letters as up here. You just have to do 2 at a time because sides are from one vertex to the other. Okay? I'm actually going to leave this on the board while you work on your homework because I think it might help you with that last problem on your worksheet. But we will do our summary. So today we learned about what? Today we learned, learned about polygons. I'm going to put and quads for quadrilaterals because we talked about the angle measures and quadrilaterals as well. All right, here comes your homework.